Let's take a look at how to find a specific value when we know the area. So in this particular problem, first of all, we're told that IQ scores are normally distributed. So knowing that the IQ scores are normally distributed, we can draw this bell-shaped curve, which for this specific question, they've already given you the graph of the curve. And we want to find the IQ score that corresponds to an area of 0.3204 to the right of that IQ score. So we're going to call that unknown IQ score right now, we're going to call it X. So in this particular question, what it represents is this. It says there's some IQ score that separates the top 32%. So 0.3204 is approximately 32.04%. All right, that separates that top 32% of IQ scores from the bottom. Okay, so from the bottom 67.96% of IQ score. So that's approximately 0.6796. So if you're wondering where I got the 0.6796 from, we know that the total area under the curve has to add up to 1. And so if I take 1 and subtract the blue area, which is 0.3204, that's where I get the area to the left, which is 0.6796. Okay. All right, so how do we find that IQ score? If you're using the Z table, because that X value is to the right of the mean value, we know that we're going to use the positive Z score or the positive side of the Z table, but you can also use your calculator for this. So let me first show you how to use the table. So at the center of our distribution, we always identify the mean value. And in this particular problem, we're told that the mean IQ score is 100 with a standard deviation of 15 points. So that means that at the center is 100. And so I'm looking for an IQ score that is above a score of 100. Okay, now how do I find it exactly? What I need to do first is I need to figure out, all right, so if you're using the Z table, I need to figure out what Z score corresponds to an area of 0.3204 on the right or an area of 0.6796 on the left. Okay. All right, so we know that at the center of our distribution, the z-score for a mean value of 100, that z-score is 0. So again, because x is above 100, we know that the z-score is going to be above 0. Okay, how do we find it exactly? So if you're using the table, the body of the table always represents the area that is to the left of the z-score of interest, okay, or the value of interest. So here, the area that we're going to be searching for in the table is the area that corresponds to a z-score, all right, of 0.6796 to the left. Okay, so let me shade that in red. So the area to the left of that z-score that we're trying to find. All right, so this is unknown. Oops. Let me use my marker here, my pen. Okay. All right, so I need to look in the table and search for an area of 0.6796 or something really close to that. So I'm going to look for an area that corresponds to 0.6, let's just round it to 8, okay? All right, so let's go to the table and see where we first see that value. So I've got so here I've got 0.6772, and then I've also got 0.6808, okay? All right, so you can either choose 0.6772 or 0.6808 because they're both really close. And so I'm going to actually just choose the first time that I see a decimal that rounds to 0.68. So that corresponds to a z-score of positive 0.46. So that gives me a z-score of 0.46. So that z-score, 0.46, is the z-score that corresponds to an area of 0.696 on the left, but that also corresponds to an area of 0.3204 on the right. Okay, so now I need to take that z-score and I need to convert it back to that x value that represents the IQ score that sits in the same spot as a z-score of 0.46. So what we're going to do is we're going to use that formula for calculating the z-score. So that formula is the z-score is equal to x minus mu divided by sigma. But in this particular instance, right, I don't know what x is. So what I'm going to do is I'm going to take this equation and I'm going to solve it for x. So to solve it for x, I'm going to first multiply both sides by sigma, so that cancels out on the right. So what I have left on the left is z times sigma is equal to x minus mu. And then if I add mu to both sides, that cancels on the right. And so this gives me a really nice formula for calculating that unknown x value when I know sigma and I know the z-score and I know mu. So here on the left-hand side, I'll just bring it to the right-hand side. X is equal to the z-score times the standard deviation, the population standard deviation, plus the sample mean. So this formula comes from the formula for calculating a z-score, and that's the formula that you would use to find the x value when you know its corresponding z-score. So here, let's just do the correct substitution. So x is going to be z, which is 0.46, times sigma, which is 15, plus mu, which is 100. Now I have to pull out my calculator because I didn't do this ahead of time. So 0.46 times 15 gives me 6.9 plus 100. That gives me an IQ score of 106.9. So that is how you would use the table to calculate an unknown x value when you know the area, okay? You can use the z-table to find the corresponding z-score and then use this beautiful formula down here to calculate that x value. Now I'm going to pause for a second here and mention that if you are using your graphing calculator, so on the bottom right-hand corner here, if you're using your TI-84 calculator, this is where you're going to want to use the function that is called inverse norm. So inverse norm is going to ask you to first type in, this is going to represent the area to the left, right, of the x value that you're trying to find. Okay, so that's the first thing that you're going to put in. So here, you can actually type into your calculator 1 minus 0.3204 if you have the area that is to the right. And your calculator will do the subtraction, and it will know that that is 0.6796. And then the next thing that you're going to type in is you're going to type in the mean value. So you're going to type in the mean value for your data. So here, that's 100. And then you're going to type in your standard deviation for your data, which is 15. And when you press enter, it will actually give you the same answer or something really close to it. So you'll get something like 106.9, and you know that that represents X. Okay, so that is how you would approach a problem like this.